Hello my friends, welcome again to my video channel. Today we will continue our work on the TS700S line. As promised, I don't show you all the steps swapping the electrolytic caps. It's not so interesting, it's more or less boring. I only show you step by step in which sequence the work should be done if you ever have the idea to do the same work, if you are crazy enough. All electrolytics and also one tantalum cap, which is here on the generator unit, are swapped. But before we tighten it with the screws again, it's better to leave it out and to replace the electrolytics on these two boards. This is the RX and RX noise blanker board, RX and noise blanker board. And this is the heterodyne board where the crystals are and the VFO is mixed and so on. There are some electrolytics. It's easier to do it now from this side, because from the other side it looks a little bit difficult to take out this board. There's only one electrolytic to be swapped, which is located here. And the RX board is behind this board. It's the FMIF board. So it's better to do this job from this side. It was rather easy to swap this electrolytic now and the three electrolytics on the RX noise blanker board also. 1, 2, 3. Here and here. By the way, I have seen that this RX noise blanker board is not the version of the TS700S, it's a version of the TS700SP Sierra Papa. It seems to be an improved version, so-called improved version. I've seen this in the addendum of the service manual of the 700S. It describes this board here. It's a little bit different from the original one. Maybe during alignment we have to use a different procedure. We will see, but in the moment the electrolytics are swapped. The electrolytics are the same, so there is no big difference in the schematic. I think the filter arrangement is a little bit different. Anyhow, we can close it, insert the screws, and insert this PCB. Then we are ready with this part. The generator board is in place now. Of course, I added the two shields. There were two brass shields on the lower side. I didn't make a footage of it. Now we will focus on the AF board. This is a carrier board and Vox board. I will start with this one. There are also a lot of electrolytics which we can see. I fear I have to remove this harness to flip it out. We will see. It looks as if I can flip out the AF board in this way. There are no wires connected, only on this side. Here the brown and blue wire a little bit too short, so I think I have to open this harness here. This wire. And then I can hopefully take it out. Carefully, but I see now I have access. It's always a danger, of course, to break here some wires. These wire wrap connections are not the best ones, and the whole wiring here is rather stiff. So it's always a danger to break something. Be careful when you flip it out. I've seen there's a second wiring in the lower side. And I have to remove this cable tie also, as it looks. Now it's perfect. We have perfect access. And now I have to flip around the whole transceiver by 90 degrees. It's not a good idea to solder in this vertical position because the solder always follows the gravity. Cannot be avoided. I have no idea how to avoid gravity. So we need to have this flat. That means I will turn it around by 90 degrees and fix it. All electrolytics on the AF board are swapped. The AF board is in place again. Small hint, check the screws of the two transistors, output transistors, and retighten them. Could be a good idea after some decades, especially this one with the plastic washer may lose some tension, so it's a good idea to retighten them, but do not over tighten them, of course. Well, that's it. Next unit is the carrier and the Vox unit. Here we have the two carrier crystals, USB, LSB, also for CW and AM mode. Here is the Vox part with a small transformer, audio transformer from the microphone. After removing 6 screws, can be flipped out, and same procedure again. The 7 electrolytics here on the carrier board are also swapped. The board is in place again. Now we are slowly approaching to the end of the swapping. The AF board is done, carrier Vox is done. By the way, in the AF board there was one capacitor more. It was not mentioned in the parts list. This parts list here in the manual was wrong. We have 19. It was mentioned on the board drawing, of course, and also in the schematic. FMIF is the next job to be done. 14 capacitors, not 15, because there's a different version regarding tone call generation. This unit here is a European version, and it does not have the automatic tone call control with a time constant of, I think, 1 second or so. So there's one capacitor less. The others are done. Mix unit 5 are still missing. So 4, 18, 23 caps have to be swapped. The next unit I will do is the FMIF unit. This one. The next unit is the FMIF unit. This part here. By the way, this here is a mechanical resonator for the tone generator, 1750 Hertz. So the symbol, I think it's a symbol for mechanical resonator. We will see how it works. Remove 4 screws and then we can flip it out and place it on a soft paper, and then we can take out, unsolder the electrolytics with a desoldering gun. The electrolytics on the FMIF board are all swapped. By the way, when you are curious and ask yourself how good or how bad the old electrolytics were, I didn't check them all. I only made a random check. Until now, roughly about 30 or 40%, not more. They were all good. I didn't find a real bad capacitor, except the big one in the power supply unit here, as we have seen, where the rubber gasket was damaged and the electrolyte came out. But all others were, as I measured, okay. All these electrolytics here I took out, also from other boards, have full capacity. They have a little bit more, +5, +10%, but there are no so-called overperformers, because I measured the isolation. Isolation is in the range of 100 megohm or so, not worse than the new ones. The ESR also was in the range of 1-2 ohms, same as the new ones had. So I didn't find up to now really bad ones, but I will do a complete examination of the old ones when I'm ready. But I don't see any signs that there is a bad capacitor. I don't know how that would behave when I will take this unit into service for a longer period. Maybe then some faults will occur. I don't know, but in the moment they look good. Well, the next one is the mixer board, which is here. I have to take out, I think, the power amplifier. I will look how it is done best. And as I've expected, the easiest way is to take out the PA unit. Loosen 4 screws, take it out, and now we have to remove this cable tie. Not to break a wire. And then it should be possible to shift it out a little bit more. The electrolytics on the mixer are swapped and the mixer is in place again. And here we have a situation which is documented by 50%. It is not shown in the schematic. I added it. It's the output, the power measurement. It's in a bandpass filter. There's a magnetic coupling with the output power. And here we have a rectifier circuit with a, I think it's a germanium diode, 470 ohm in series, and an electrolytic 4.7 microfarad. And this goes to the pot of the S meter and feeds strength meter. This is not shown. It was shown a straight line, but the high frequency is not fed to the board with the trim pots. So this is missing in the diagram. But interesting, it is shown in the part list. Bandpass filter unit, electrolytic, diode. But the resistor is not shown. Anyhow, this is done also. This is the 4.7 microfarad. I mounted it on top of the pin rows here. It's a little bit easier than in the original situation. Well, the last 3 electrolytics are in the power amplifier and the PA. There are 3 electrolytics. One, and I see 2, 3. Here is one. Here's one. They can be easily swapped. They are soldered on the side of this box. And these are the last 3 electrolytics who have to be swapped. The last 3 electrolytics in this project are swapped. 1, 2, and here's a third one in the PA. And now all electrolytics and tantalums, 2 tantalums, are swapped. Totally we're at 104 electrolytics and 2 tantalums. I think this deserves a drink. Prost. But before we can continue in this project, we should remove a modification. I've seen this white wire. I really didn't understand what it is for, and I followed it. It's a plus 24 volt or plus 20 volt line, which supplies a higher voltage to the PA. It comes out of the power supply unit with a voltage doubler. But this 24, or is it 24? Yes, 24 volt goes to the microphone. This wire. It goes to 1 pin, which should be grounded according to the schematic, but it isn't grounded. The ground lead is here. It's isolated by this blue heat shrink. I will remove it. Seems someone had a microphone amplifier connected here or so, and he needed the power supply, but it's dangerous to have here 24 volt on this microphone connector unfused. Sorry, it's not true, it is fused, but it's behind this big fuse, which is 2 or 3 amps. So it's not a good idea to have it. I will remove it. I don't need it, because all important functions are here in the TS700, Vox, etc. So what it is good for, preamplifier, the microphone is sensitive enough. It doesn't need a preamplifier. Let's remove it. Job is done. The black wire is now connected to the ground pin again, as it should, on the microphone, and the white wire is out. Now we can go to the next step. The next step is cleaning all switches, pots, whatever we have on the front panel. Some are a little bit noisy. The AF pot, also some of these switches. I will do it with, of course, some contact cleaner, not too much, only some drops. Do not cause a tsunami or something like this. Only use some drops. That's in general enough to get the contacts, switches and pots cleaned. Before we can focus on the next topic, that is the preamp. I have a feeling the preamp here, receive for DX, is not operating. I have to set the S meter to 0, not as in perfect alignment, but just to have the S meter down to 0 to see the reaction of the preamplifier at low input voltages. The setting is done on the RX board. And here we have the setting. I go down to 0. That's it. Full scale. I don't know what S9 is specified, but I have a signal now fed in. It's a weak signal in the range of 0. Let's go to 0.3 microvolt. It's 0.3 microvolt. Now we can see the S meter moves up, and when I switch on the RX amplifier, the preamplifier, we can see the signal drops, gets weaker, and when I switch it off, the preamplifier, the signal gets stronger. That's not what it should be. So I have the feeling there's something wrong. Maybe I have to clean the contacts of the relay, or the preamp transistor is faulty. Here we have the circuit under discussion. This is the input coming from the antenna relay. This relay is not the antenna relay, it's the switching on or off of the preamplifier. At this position, the signal is fed through this relay to the first transistor, but when the relay is activated, the signal is fed down to this transistor, is amplified, fed back, and then fed into the first transistor. So this is a preamplifier. I see here some notes. Someone made a note on it. I don't know exactly. He made a circle around it. This is not a good sign. Seems like an interruption here in this line. Anyone tampered with it. So maybe there is a modification made which is not perfect. Let's have a look into the board. Here we have this relay. We have signs of soldering damage. This is the antenna input. It's also not original. Someone soldered here. This is a preamp transistor. This little white spot. This is switched on by this relay or off. And here we have the RX path, and the first transistor is located under this FMIF unit here. So maybe we have a problem inside with the switching of the relay or a bad transistor. But now to the correct diagram. We have the version SP, TS700S P, Sierra Paula. So the RX unit is a little bit different. And we don't have here a field effect transistor. We have here BJT, bipolar junction transistor, type 2SC1070. And this type is indeed installed. I read it on the case of the transistor. So we have this version, but the principle is the same. Switching on off of this transistor via this relay. And now I will check all the voltages around this transistor, base emitter voltage, collector, and so on, whether we have any problem here in the DC supply. Here we have on the board the layout. the preamplifier. Please note this drawing here is mirrored. It is a look from the bottom side onto this board. So what is here left is here right, and vice versa, but the transistor is rather centered, but the collector, which is shown here on the right pin, is here on the left side. And when I measure the collector voltage, I can measure 8 volt. This is RXB, and this is in line with the drawing. By the way, there is no difference when I switch the RX on and off. This voltage is always present. Here we have on this side 1.4 volt. This is the emitter side. This is this side. We have 1.4 volt. Sorry. And the base are these 2 pins. We can measure 2.2. So the base is 0.8 volt above the emitter, which is okay. On the other side I also measure 2.2, and again here we have 1.48, or let's say 1.5, and 2.2 is 0.7 volt difference. This means the transistor has reasonable biasing, reasonable behavior, so I assume that the problem is not the transistor. The relay itself, I removed the cap, seems to be okay. When I switch the preamp on and off, we can see it activates, and the set of contacts is here on the upper line, so I can clean them now. A small sheet of blotting paper. When I switch the relay on, the contact is closed, and I can move the blotting paper through the contacts. I use contact wash, not a contact cleaner, but I don't see any signs of dirt. I will do it in the other way around with the other contact. There is a minimum of dirt which I could remove, so I think the contacts are clean and not the cause for this problem. And now I have to do what I wanted to avoid. I have to take out this unit, this RX unit, and to check the wiring on the bottom side, what's going on there. I'm quite sure the problem is on the bottom side, maybe bad solder connections or any modification, I don't know, but we will see. The RX board is in test position. The FMIF board could be flipped out, we know this. Here I have added 2 yellow plastic shields to prevent any short circuit when the RX part is vertical. And now here's the relay. And here we have access to the lower side of the relay, and then we can check the behavior just to compare it. The relay is this one. We have here the coil, and here we have the switch over contacts, and in case of RX without amplification, the signal goes from there to this point, to this pin, back, and then via this capacitive diode and the first circuit to the first amplifier. And in case of switched on preamp, the signal goes from there to there over this first filter to the transistor, to the emitter. It's a base grounded circuit, and this is the output, and the output goes via this contact back to there. So when the RX preamplifier is switched on, we have contact from here to here and from here to here, and when the RX preamp is switched off, we have contact from here to here and from here to here. So first we check RX preamp switched off, which works, but just to verify, we have contact from here to here and from here to here, or let's say from here directly to here. And this we can check. The preamp is switched off. and the you can see it, one moment, a little bit better, and the contacts in question are these two contacts. This is the center pin, and this is the contact, and this is the contact, or to say we have contact from here to here. This is when the relay is switched off, and now we switch on the preamp. When the preamp is switched on, we should have contact from here to here. We have no contact, and also not from here to here. Seems the relay does not move correctly. And from here to here we also have no contact because the relay has moved. Now I switch back, switch the RX preamp off, and then again we have contact from here to here, and of course no contact. Sorry, that's the wrong pin. We have no contact from here to here. And when I switch it on again, still no contact from here to here. Also not from here to here. This means, and of course not from here to here, this means the preamp relay is not correct. I will take it out and check it outside of the board. The problem inside the relay is solved. I bended these contacts a little bit more. Maybe they lost their strength over the decades. And now we have a contact when the relay is activated from here to here and from here to here. And when I energize it, then we have contact from here to here and here to here, and of course not from here to here and not from here to here. And when I apply voltage again, oops, then again we have contact from here to here and here to here as it should. I will bring back the relay again into the board and see whether it works now. And now first success, when we switch on the preamp without input signal. Maybe you hear the increase in the noise. That means an additional amplifier is in the stage. And now I will try it with an input signal. Here we have an input signal of 0.2 microvolt without preamp. And now I switch the preamp on. Watch the S meter. And on again. Off. On. Don't let you be fooled by the short jumps. It's caused by the switching. The switching pulse is much more stronger than the input signal. So when we switch the RX on preamp, we always have a small jump, but the settled amplitude is constant. I can increase the input level a little bit. Now I have 0.3 microvolt. Okay. Off. On. The S meter is extremely non-logarithmic as it should. It is not logarithmic. It should be logarithmic, but such simple S meters are not good. They only give a rough indication, not more. Well, this problem is solved. The preamp is now working. The reason was a bad relay, which didn't switch properly, and I think now all problems are solved and we can go to the next point, to the complete alignment of this transceiver. I don't know any other problems, so I'm sure we can go to the alignment and we don't see any further surprises. This is the end of part 4. We finalized the swapping of all electrolytic and tantalum caps. We have rebuilt a modification regarding the microphone connector. The plus 20 volt line was connected to there, and the main topic was the repair of the preamplifier. It was a relay, luckily not the transistor. It was only a bad relay. I hope it's good now. Maybe I will swap the relay in a later work, but in the moment I'm just looking for all faults. End of part 4, and in part 5 we will do a complete alignment of this transceiver. I will show you the whole procedure, and I have to do it, of course, because due to the work I have done, it's necessary to realign everything. I'm sure it's interesting for you. Stay tuned, stay healthy, see you on this channel.